All right, so there we go. So find the domain of that function. All right, so how do we find domain? Yeah, it's all about denominator not equal to 0, huh? Denominator can't be 0. All right, so what do you think about that one? Well, go ahead, finish that one up if it's not immediately apparent. All right, so move the 10 over, becomes a negative 10. And then we put the root over both sides and plus or minus. And what does that mean? Yeah, imaginary, huh? So what does that mean? That means x cannot be imaginary. Okay. So that means x is any real number. In other words, any number. So this would be the domain is set of all real numbers. It just can't be imaginary. Well, all right, it won't be imaginary. It'll be real. Make sense on that? So it's all real numbers. Because there's no way to make that denominator 0, right? Because remember, in the domain, for domain, we're asking the question, where are the trouble spots, right? What can, like the knives into the toaster, what can you not insert into this function? Can't put knives in the toaster, so knives are not allowed in the domain, the acceptable inputs for the toaster, right? So that's what domain is, acceptable inputs. And so we're saying, well, the denominator can never equal 0. Because if you make the denominator 0, that's going to choke the function. And so we solved that, and we said, well, x cannot be an imaginary number. So that's no restriction at all. X can be anything real. Good on that? All right, so that's number 4. All right, try that one. Same thing, domain. So denominator cannot equal 0. Like that. So what do you do about that 10? You could, but we like things factored. We could factor the rest of the way, huh? X plus 9, x minus 9, like that. Right? Hey, what if that was x squared plus 81? I know I ask this every day, don't I? It's like my everyday question. But what if that was plus 81? Could we factor it? The answer is no. You guys, if there's nothing else you're going to be clear on after this class is over, it's you cannot factor a double added, right? Just the minus. All right. So anyway, so what do we do now with that 10? Really nothing. You totally ignore the 10. You only set the parts that have x's not equal to 0. Why? I don't want that just to be something Mr. Heron says. Oh, well, it's because it doesn't have an x. If it had an x, it was like 10x or something, then I would also say that part can't be 0. But if it doesn't have an x, then it doesn't have a variable, and it cannot vary. It's only 10. So in other words, logically, reasonably, it's like if I said to you, hey guys and gals, 10 times something, is equaling 0. That's what this equation is saying to me. Right? It's saying 10, just think real life. If somebody said to you, hey, 10 times something is coming out 0. Well, that means one of these somethings must be 0. Right? Doesn't mean anything about the 10. That could be a 3. Who cares? Anything times, if one of these is 0, it doesn't matter what the number in the front is, it's going to multiply to be 0. So it means nothing about the 10. So any part that doesn't have a letter, we just ignore. Right? Because it can't make anybody 0. It's just 10. All right. So then just solve these two. Jump it over. So x cannot equal negative 9, and x cannot equal regular 9. So those are the two things x cannot be, negative 9 or regular 9. Is that good there? Questions on that?
Can you put like plus or minus in front of the 9, or does it have to be two separated?
Yeah, I think it has to be two separate, but they do allow you to do like this, not equal to, and then just put comma with the both of them. I'm pretty sure that's how they do it on that. All right, whoops. So let's. Okay, so first off, domain and range. When they give us a picture, see, you guys seen how this works? They're always doing this. They're asking us questions, domain, about an equation, and then now they're asking us about a picture. Same question. They're saying, what's domain? They were saying domain on the last problem, but they didn't give me a picture on the last problem, did they? They were just giving me an equation or a function, right? No picture, and saying, what was domain? Now they're giving me a picture, and they're saying, what's domain? So what do I do for domain when they give me a picture? How do you answer domain from a picture? It's the width, huh? It's the left edge, right edge thing, isn't it? Yeah. So you just look at the graph and you say, how far left does this graph go? And how far right, that's the domain, right? It's left edge, right edge. So where do we see graph? The graph's the blue, right? Where do you see graph? Well, it looks like it goes forever left, doesn't it? That little blue part is it just keeps going forever left and forever down there. So it looks like it goes forever left. It also goes, right here it goes forever right, it looks like. Here's forever left. So there's only one spot it doesn't hit. And that's, what is that, -2 there in the middle right here? Okay. So domain and range. Finally, can you tell, that one's just weird to look at. Let me add to the graph. I think I can make it more clear. Do you realize what they're saying? They're saying this is straight up and down, this, vertical. And they're saying here's a slant, so this would be the oblique asymptote, the diagonal slant asymptote. So let me just add, I think it'd be more clear if you had to. And then the graph, that almost looks like two straight, like parallel lines or something. That's not what they mean. They're not being very clear. What they mean is, like, it goes like this. And like that. And this part goes like this. And like that. That's what they really mean. How do I know? Well, because asymptote lines are guidelines. Graphs follow the guidelines, huh? They follow the asymptote lines. So that's how I know that's what they must be indicating. Whenever you draw a piece of a graph headed towards an asymptote line, you know what it's going to do. It's going to get forever closer to that asymptote line. It's going to, get closer and closer forever. It's a guideline. So there's a picture of the graph. So let me let you answer all the questions now that that's a little more clear. See if you can answer domain, range, intercepts, horizontal, vertical, asymptotes, and oblique. I'm going to run through roll while you do that real quick here. And Maria Aguilar and Christine is here, and Terrence Alvarez, and Alexis Avita, and Osberto, and Carissa is here, and Stephen Blancas is here, and David and Enrique Camacho is here, and Christopher Cano, Javier, and Joanna Cisneros. Hello, Joanna. And Karina is here. And Nicholas Escobedo is here. And Andrea Garcia is here. And Destiny Garcia. Destiny. And Devin Gill is here. So, let's go through the questions. Domain and range. So domain, well actually it's going to be on the graph, huh? So the domain is like left edge, right edge. So how far left, the domain, how far left does the graph go? Well, left forever, because this branch right here goes down and left forever, right? Because that asymptote line's going down and left, so it's going to go left forever. So left forever. And then it's also going to go right forever because this branch goes up and right forever. It's going to go left forever, right forever. The only spot it's not going to hit is right in the middle at 0, huh? It's going to be from there to there, from negative infinity to 0. Because you never, oh yeah, let me mention, it's important. You never hit a vertical asymptote line, but you can hit the others. Let me write that. You never hit a vertical asymptote line. You never do, because that's where the denominator is 0. And you can't have the denominator. There's never, a graph will never touch a vertical asymptote line. But you may hit a horizontal or oblique diagonal asymptote. You can hit horizontal and oblique ones, but you can never touch a vertical because that's where the denominator is 0. Yeah, so we know it doesn't touch that vertical at 0, so the domain, therefore, is negative infinity to 0 and 0 to infinity. That's the domain. So I'll write that. Okay, so now, and I think in this section, all of a sudden, they don't want you to put U's in between them. I don't care on the test. But if I remember right, in this section, they have you just list them with a comma between them. Remember earlier, they always wanted us to put U's in between them?
It did it as an inequality, like not equal to.
Oh, did it? Oh, it just said x not equal to 0. Oh, okay, that's even easier. All right, so I lose track of what they do where and when. So any of those are fine with me on a test. I don't care. If you're wondering how I'll grade your test, the one you just took or other ones, yeah, I'm not picky. As long as it's saying the truth, I'm happy with any form of the truth. Okay, what's the range? Range would be the up-down, huh? And let me see. Does it goes as high and as low as you'd ever want. Oh, the range is everything, huh? The range would be negative infinity to positive infinity, right? Because the range, the up-down, the range, it goes as high and as low, and it doesn't skip any values. High and low as you'd ever want, from negative infinity to positive infinity on that. That good? On that, what do they have you say then if they're...
It just says the
all reals.
Numbers.
All reals, yeah, same thing. And this is all reals, yeah. Good, okay, good. So now, part B, intercepts. What are the intercepts? Oh, they're right on the graph, aren't they? Negative 3, 0, and 3, 0. They're just giving them to you, right? So those are the intercepts. Those are easy. Okay, now what about horizontal? There's no horizontal. Vertical, the vertical asymptote is right here in the middle. So that's x equals, or it hits the x-axis right there. Right, that vertical line hits the x-axis at x equals 0. Now, what about the oblique? Let's go to a new screen for that. So, all right, so last one, oblique, that's diagonal. They also call it slant. So the diagonal or slant or oblique asymptote. We're looking at it right here. We need the equation of it. How do you do that? Well, that's a y equals mx plus b. Because it's a straight line, huh? And it's not vertical, and it's not horizontal. So it doesn't just have x or just have y. It has both, because it's slanted. You with me on that? Everybody good with that basic fact, right? If you're straight up and down, you just have one letter. If you're straight sideways, you just have one letter, depending which axis you hit. But if you're slanted, you're going to have both letters, right? So you're going to hit both axes. So both letters are in there. So how do we do it? Well, you guys know, huh? Can we find the slope first off? The m is the slope. What can you tell what the slope of that slanted line is? Rise over run? Yeah, because it's rise, run, right? It goes up, what? Up 10 over 2. Am I doing that right? Yeah. Up 10 over 2. So rise, run, 10 over 2 would be 5. Slope would be 5 there. That good? And so there's the slope, 5x. And what's the b? Yeah, just 0, huh? The B is right there. The B is y-intercept, remember? It hits, where does it hit the y-axis? At a height of 0. So there's the diagonal. You can just say 5x, the oblique asymptote equation. The equation of that dotted line that's slanted, y equals 5x. Good on all those parts? Not too bad? All right. So y equals -3 plus 1 over x. All right, so what I'm going to do, it's multiple choice, but it won't be multiple choice on our second exam in a few weeks, right? It'll just be, hey, draw me the graph. And it'll be the same way the other graphs were on part 1, where I say, show me a center point and one other point. You know, that's the easiest way to graph, I think. So let's do that. So let's do x, y. Oh, and by the way, what basic look? You always have in your mind, it's one of our basic 6, right? What's the basic look of this kind of graph? It's these, huh? It's the asymptote lines, the vertical and the horizontal crosshairs, the asymptote lines, and the two branches that are diagonally, one diagonal or another diagonal, apart from each other, right? So that's the basic idea. We're thinking, oh, okay, yeah, this is basically 1 over x. 1 over x has the vertical and horizontal and has the two branches, right? That's the basic idea. They can move them and shift them and flip them and stuff, but basically we got to find the two diagonals, the two asymptote lines, the crosshairs, and then the branches will be in two diagonal quadrants of those asymptote lines. All right, so with that in mind, let's find the center point. How do we always find the center point on all of our graphs? 0 out the x zone. What's the, in this case, that's just x. There's nothing else there with it. So that would just be 0, huh? So we'd get y equals -3 plus 1 over 0. Now, what is 1 over 0? It's undefined. You can't have 0 in the bottom of a fraction. But remember what we do with undefined? For graphing anyway? We pretend. You can say that word, it's okay. We pretend it's 0. We just pretend it's 0. So -3. We just treat it like 0. We pretend, not the whole thing, but just the undefined part is 0. You guys with me? Do you remember this? Right? I hope you don't feel that we're going crazy here. We've been pretending in math for a long time. You've been dealing with imaginary numbers, right? This isn't anything new. We pretend. In fact, all of math is made up, but we do it to help us find things that are real. So we're finding, that'll help us find the asymptote line, where they cross, I mean. So over 0, down 3, right there, that's the crossing of the asymptote lines, right there. Right there, very important point. So super important is to find that point. Is that good? So again, so you plug in whatever, 0 out the x zone, and then you get the undefined. You pretend the undefined part is 0, and you get the y value, and you find that center of the crosshairs, center of the asymptotes. Now what do we always do to find the other point? We always add 1 to whatever our first x value was. Plug in 1. What are we going to get there? Y equals -3 plus 1 over 1. Y equals -2. So over 1 down 2, right there. So over 1 down 2. This one's over 0 down 3. So we got our center dot and our one other dot. What in the world does that tell us then about the graph? That tells us the graph is in this quadrant of the asymptote lines, huh? That portion, that quadrant of the asymptote lines. And where's the other branch? Yeah, down here, diagonal, right? Because they're always diagonal, aren't they? Now, if my first dot, my other dot had been like over here or something, then that'd mean I'd have a branch here and a branch here, wouldn't it? So you just let that other dot tell you where one of the branches is, and then you know where the other branch is because they're always diagonal. And there we go. That's all I'll ask for on the test. And can we tell which one it is, A, B, C, or D? Oh, yeah, it's easily, obviously C, isn't it? That good? Everybody make sense out of that? Should we try another one? All right. So let's try that one. So y equals 2 over x minus 2 squared. So it's going to be another one of these, you know, x is in the denominator, so it's going to be find the two asymptote lines. Just go ahead and do the normal thing. Do the xy, find the center point, find one other point, draw your axis, find your crosshairs. Very, very similar. What are we going to plug in for x to zero out the x zone? Gonna plug in 2. Gonna plug in 2. All right, so we're gonna plug in 2 because plugging in 2 right there is gonna make x's little world, the parentheses with x, gonna make it 0. So it's gonna be 2 over 2 minus 2 squared, and that's 2 over 0. Undefined, and what do we pretend undefined is? We pretend it's 0. So 2, 0. That means over 2 up to right there is the center of the crosshairs, the center of the asymptote lines. Good? Makes sense? All right, now what do we do to find the other? We add 1, put in 3. What are we going to get? Y equals 2 over 3 minus 2 squared. 2 over 1, 2. Right, so we always just add 1 to whatever our first x value was, right? Whatever your first x value was, 2 in this case, add 1, get 3, plug it in. So over 3 up 2, boom, there it is. Over 3 up 2. Okay. Are we ready to graph? So we know there's a branch here in that quadrant of the asymptote lines. Now, you guys track with me up to now? Up to now, it's been really nothing new. You okay with all that? Does that make sense so far? Because now comes something new. Got it. We got to find where that other branch is. Now, notice in the beginning, probably you were noticing all along, that it says squared here. Right? It's not, if they had given me y equals 2 over x minus 2, not squared, then I would have just said, oh yeah, well, it's there and it's there. Done. But they gave me squared. Do you remember, what do you think having the x piece squared does? Do you guys know what the graph of, you know the basic graph, y equals 1 over x, we know that. That's the, diagonal, and then boom and boom, right? But what does 1 over x squared look like? It has the same asymptote lines. Can you see this down here? So I'm comparing 1 over x, which has diagonal, x squared. Think about 1 over x squared, guys. X squared is always what? Positive. They're both up. That's the only difference. Because x squared is always positive. You can't make x squared negative. He's not going to have a branch down below. Not going to have a negative branch. Well, that's not entirely true. If you throw a negative in front of him, they'll both be down. Because then he's always negative. Really, the point is x squared can't change his sign. Whatever's in front of him is always his sign, right? Because x squared cannot change his sign by plugging in different x values. Whatever's in front of him, if there's a positive in front of him, he's always positive. If there's a negative in front of him, both branches would be down, wouldn't they? So the point is, for x squared, the branches are side by side. For regular 1 over x, the branches are going to be diagonally across from each other. Does everybody see that? So that's the idea. That's what you want to put in your 3x5 card or into your long-term memory banks. So that's the difference between 1 over x and 1 over x squared. So for x squared, the branches are always side by side. So if you find one of them, you know where the other one is. For 1 over x to the first power, just first power, the branches are going to be diagonally across from each other. All right, so getting back to our graph, we found that we have a branch in the upper right, so the other branch is upper left, isn't it? Side by side. They've got to be side by side for x squared. That's because we have x squared. Questions on that one? Everything else was the same, huh? The only thing we did in the end was side by side. All right, get moving. I want to make sure you can do a few of these well. All right, so try that one. If you can graph that one. Is that one squared or not squared? Not squared, right? So the branches are going to be diagonal across from each other. They're not going to be side by side. What do you plug in to find the center point? -9, right? Because putting in -9 will zero out the x zone. So that's undefined, and we say 0. So there's the center point, -9, 0. Now just add 1 to that, right? Whatever our first x value is, the center point, add 1, that'd be -8. Plug in -8 now. It's the easiest way to go. Plug in -8, you get what? -9 over -8 plus 9. -9 over 1, -9. Good to there? All right, go to the graph. Boom, there it is. Back 9, up 0. There's the center of the crosshairs, the center of the asymptote lines. Is that good? And put our asymptote lines there. Cross right there. Okay, so now where's the one other point? Back 8. So this is back 9, this is back 8. Back 8. Oh, down 9. I'm way out of room. I'm just going to pretend it's right here because I'm way out of room. Back 8, down 9. So it's somewhere way down. It's back 8, way down. It's out of room. So put it right there. So that tells me about my branches, right? So one of the branches is down here. And where's the other branch? Is it side by side or is it diagonal? It's going to be, this is x to the first power, huh? So it's diagonal. It's up there, isn't it? If that was x squared, they would be side by side. They would both be down. But because it's x plus 9 to the first power, really, then they're diagonal from each other. Is that making sense? It's all about whether they're first power or second power. That's the new wrinkle. So it's all about asymptotes. So today's all about asymptotes. All right, questions? You guys have no questions at all. Please speak up. Is it all making sense? Oh. All right, so try that one. What do you got to do to graph that one first off? You got to do something about his denominator. What could you do? Factor, right? Factor that denominator. It must be factored. And how does that denominator factor? Like that, huh? X minus 5 squared. We good? That's x minus 5, x minus 5. So if you're having trouble with factoring, you need to address that. And the way to address that is guess. So if you think, oh, I don't know if it was that, you just write it out and you just try it. X squared minus 5x minus 5x plus 25, and you go, oh, that's x squared, what? Minus 10x plus 25. You go, oh, yeah, that's right. That's what you got to do. So if you're looking, going, I don't know how to do that factoring, my counsel to you is guess, foil it out, and you'll start learning. But if you just stare at it and don't do that, you won't learn. It's just simply practice. You just got to foil, 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 so many times that you can foil in your head pretty soon. And then you can, because factoring is foiling backwards. That's what it is. It's looking and saying what would FOIL to be x squared minus 10x plus 25. So the more you FOIL, the more you'll be able to FOIL backwards, which is called factoring, right? So if you're not sure, just guess, FOIL it out. If it's wrong, change it, FOIL it again until you've got it. It just takes time, no shortcuts. So all right, so we've got it factored. So now we just go on and do the regular XY chart. Find the center point. In fact, can I just go dot, dot, dot? I'm going to go dot, 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 dot. All right, try that one, guys and gals. That one is more complex. It's already factored for us, though. We don't have to mess with factor. So make the XY chart, find the center point, find one other point. No, the one's important. Yeah, good question. That one's going to matter. But just do the regular. So what I mean by regular is XY chart, find the center. So what do we plug into, didn't write that very nicely there. What do we plug in? Just zero out the X zone, right? What's going to zero out the X zone? Positive regular 1, huh? Everybody get it? It's just the parentheses where X is. I'm not making the whole thing 0. I'm just making that piece 0, right? So plug in 1. Everybody good with that? You plug in what will zero out the X zone. All right, when you plug that in, what do you get? 3 over 1 minus 1 squared, which is 1 plus 3 over 0, which is 1 plus undefined. And remember what we always do with undefined? We say the undefined part is 0, so that's 1. So that 1 in the front did matter, huh? Does that make sense? But the undefined part, we pretend is 0. How are we doing? You guys look tired. Are you tired?
It's the weather.
The weather? The weather's funny. Does it feel stuffy in here? Is it stuffy? I don't know why they make it. It's always funny weather in these older buildings. Well, I guess this is a refurbished building. All right. Anyway, 1, 1. Over 1, up 1. There's the center there. So that's the center of the crosshairs. Most important point on the graph, right? Because that'll really help us find things. So put that in there. The center of the crosshairs. Over 1, up 1. All right. And now you know what to do. Find the other point. Add 1. Get a 2. Plug it in. I don't know what you get. Bring it over here. I'm out of room. What y equals 1 plus 3 over 2 minus 1 squared. Y equals 1 plus 3 over 1. 4? Yeah, 4. Over 2 up 4. 1, 2, 3, 4. Over 2 up 4 right up there. Over 2 up 4. All right, so there's the center point. There's one other dot. You know what to do from here, right? So we put a branch in the upper right. Where that dot, wherever the dot is, that's where one of the branches is. That's the purpose of that dot. And where's the other branch? Is this a side-by-side or a diagonal? Yeah, because it's second power, it's side-by-side. If it was first power, it would be diagonal, right? We good? Feel like you guys can crank through these? The greatest of ease? Questions I can answer? Because we got bigger stuff. Do the first couple of steps on this one and then dot, dot, dot. Once you get through the algebra, it's the same as the others. So, all right, they're giving me this function. They're saying y equals 8x squared minus 3 over x squared. In that form, we're not ready. You can't really do what you need to do. I don't know why that keeps flickering like that. Anyway, you know what you need to do is you need to separate that like this. And then you can cancel. And then it becomes 8 over 3 minus x squared. And then I'm going to go dot, dot, dot. The rest is just like the last problem once you've done that. Does everybody see what I did there algebraically? let's talk about algebra for 1 minute or so, or a minute and a half, 2 minutes. Because it's really important as you go into calculus. You know, that is really the reason people don't make it through calculus. It just requires tons of algebra, like really good algebra skills. Like you can't be the kind of person that messes up every 2 or 3 steps in algebra. You know, like you got to really know that stuff. So I want to take every opportunity I can to help you with that, because you can do it. You just got to practice. For example, let me ask some algebra questions. Could I have canceled these x squareds on that previous step? No. Why not? Do you know that? You need to if you don't know that. You will die. You will fail in calculus if you're not clear on things like that. That and things like it. Because it's all over the place in calculus. Like all the problems will have half a page of algebra. Again, you can't be messing up every 3rd step or you'll just never get anything right. So why can't you cancel that? Do you know that rule from algebra? What's causing the problem there? It's the minus sign. Do you know it's the minus sign? If it was 8x squared times 3 over x squared, you could totally do it. It would be fine, and you should. But if you have a plus or a minus, you may not. You need to know that crystal clear when you go into calculus, especially. It'll kind of need to know it this semester if you want to get an A as well, but just to survive in calculus. Let's talk about that for a minute. Whenever I teach algebra, have I said, I don't want to repeat myself, I forget what I've said. Have I talked about Costco and glue and plus or minuses? I said a few words about that, so that's that again, right? Pluses and minuses glue things together. So you really want to know, it's a really important algebra rule. Pluses and minuses, like Costco or Sam's Club, those places that connect 2 melts together. You can't buy just one, right? So that's what pluses and minuses do in the world of algebra. They connect things. So what that means is, when something has a plus or minus, let me rewrite it here, 8x squared minus 3 over x squared. That minus sign says that 8x squared and that 3, they're stuck together. Meaning, if you want to cancel them, you can, but you go like that or you don't touch it. You buy the whole package or you don't touch it because it's glued together. It's a package deal. It's all or it's nothing. You can't take part. You can't just take the 8 or the x squared or the 3. It's all glued together. So pluses and minuses do that. Therefore, what do? We separate it. That's why I do this. So you wouldn't even think to do that if you didn't know about that rule. Then you separate, right? That's just common denominator backwards, right? Right? That's just same denominator, break it into 2 separate. This is common denominator. Right? Now, I can cancel here with the 8x squared over x squared. These can cancel. Why? Because that's just times in the middle, huh? That's just shopping at Save Mart. That's fine. You can buy just one, right? It's fine to cancel just the x squared there. So we get this, and that's what we're used to dealing with, right? That's, do the XY table, plug in 0, blah, blah, blah. Make sense? We good with all that? All right. Please grab me. Anytime you have trouble with algebra in the homework, grab me after class. If the last night's homework or before, I'm glad to help. That's what I want to do for you guys, is shifting gears. We're completely shifting gears. All right, so all that other stuff is over. It's like a total change gears right now. We're changing to something completely different. We're in the same section. But now they're going to give me an equation and ask me about the asymptotes. You might be thinking, we've been doing asymptotes for the last hour. From pictures, not from equations. See the difference? Is the game they're always playing. They ask you stuff with pictures, they ask you stuff with equations. They ask you stuff with equations, they ask you stuff with... Now, we're shifting gears. They've been asking me horizontal, vertical asymptotes and domain and range from pictures. Now, they're going to ask me asymptotes with no picture at all, just from a formula, just from a function. So how do I find the asymptotes from that function? What am I going to do? Well, that's my job to tell you, huh? All right, let me give you the rules. So how you find a vertical... So I'm going to give you steps. You need to write these steps down. And then I'll try to reason with you logically after I give you the steps. Logic is always better, but steps can be helpful just to get the ball rolling. So here's the steps. When somebody gives you no picture at all, they just give you a function. They say, hey, what are the vertical? Does anybody know? Let me just ask you. Do you know, how do you look at that function and just automatically know where the vertical asymptote lines are going to be? Nobody knows? No idea at all? What's that? Good thinking. Yes, exactly, right? Because vertical asymptotes happen where you can't go, where the domain says don't go here, right? Because remember, you can never touch a vertical asymptote. Remember how we said that a few minutes ago? So that's a no-fly domain zone. So it's basically the domain thing. It's totally right. There's one extra step. You do have to factor top and bottom and reduce if possible. And it's usually not possible. It's not possible on this one. I have to write it in because every now and then, it's a rare deal, but it is possible every now and then. So get that out of the way. Then, yeah, totally just like the domain thing, except you say denominator equals 0 and solve instead of not equal 0. Because we're not restricting, we're trying to find where the vertical is, which is a restricted place, but we're trying to find it. So yeah, so you look at that function. Can you factor and reduce that thing? No way. Can you cancel? Can I cancel those x's? 13x over x plus 5, can I cancel those x's? No way. The bottom says, I'm a package deal. The top is fine. That 13x on the top is ready to be canceled. That's just times, no problem. But the bottom says, no way, I'm glued. If you want to touch x plus 5, you buy the whole package or you don't touch it, right? It's all or it's nothing. All right, so get back to it. So what do we do then? So skip, step 1. We usually skip step 1. Step 2, denominator equal to 0. Just like domain, except it's equal to 0 instead of not equal to 0. Why? Because I'm not restricting it. I'm trying to find where it's at. So move it over, x negative 5. What that means is if you go to x negative 5, 3, 4, 5, there'll be a vertical asymptote line there at negative 5 on that graph. If you were to see the graph, there'd be a negative 5 vertical asymptote, meaning the graph would rise up or rise down, right? I don't know exactly. I'd have to graph it, but it does something like that at negative 5, meaning it can't touch negative 5 because negative 5 makes the denominator 0, doesn't it? Makes the denominator 0. So it's not allowed in the domain. See why you never touch a vertical asymptote line? Because it's always a denominator 0, not allowed spot. And by the way, let me give the logic now. So I just gave you a rule, but now logically, why is that where there's a vertical asymptote line? I mean, I understand it doesn't exist there. I think you know that. No-brainer. Obviously, you can't make the bottom 0. But why does that make the graph rocket up or rocket down? Why does that happen? I understand you can't go there. You can't have the bottom 0. That's undefined error on the calculator. But why does it rocket up or rocket down? Why do graphs always do that at a vertical? That's what an asymptote line means, right? It goes to that line. And a vertical means goes up or goes down super fast. So why does that happen where the denominator of a fraction is 0? Do you know? What happens when you take any fraction and you let the bottom get really close to 0? Let me get a new thing here. This is what you want to ask yourself. This is what you want to do. This is what people who make it in math and science learn to do. It's not about memorizing. I mean, I'm writing steps, and you can put them on your 3x5 card. But that just won't make it long. Honestly, it won't. Calc 1, Calc 2, physics, chemistry. If you don't get it, you're not going to get it. If you don't spend time thinking about why is this really happening, and you just try to monkey see, monkey do all the time, just follow the rules, there's going to be a point where there's way too many rules to monkey see, monkey do, and you need to get the logic. So push yourself to the logic. So think what I'm thinking right now. I'm saying if you take a fraction, when the denom goes to 0, the fraction goes to infinity, positive or negative. Have you ever stayed up late on a Friday night thinking, why does the bottom of a fraction becoming close to 0 make the thing go to infinity? I know you're thinking, that's what weird math teachers do, and that is what I do. But you want to be that way too, right? If you want to go into math science, you got to do that. So let me just, here's what I would do. Here's what I learned to do in my little math science years, is I would just play around with numbers. I learned so much by taking my calculator in my hand and fiddling with numbers. Here's what I mean. Take 100, okay? Just pick a nice, easy number. And then divide by 50. What do you get? Well, 2, okay? Now let the bottom get smaller, 25. What happens to the answer? Bigger. Let the bottom get even smaller. What happens to the answer? Bigger. Let the bottom get even smaller. What happens to the answer? Let the bottom get even smaller. Let the bottom get even smaller. Let the bottom, can you get smaller than 1? Yeah, how about a half? 0.5. How many 50-cent pieces in $100? 200 of them. Let the bottom get even smaller. How about 0.1? How many dimes in $100? You see what's happening, guys and gals? You ever thought about that before? If the top of a fraction stays fixed and the bottom gets smaller and smaller and smaller and heads towards 0, basically 100 over 0 or anything over 0 is infinity, is what it really is. I mean, I know we say undefined, but really it's infinity. And if there's a negative in front, well then it's negative infinity. I don't care about sign. It's some kind of infinity, right? You realize that? That's what it really is. 0 in the bottom is infinity, right? See where it's headed, right? How many pennies in $100? I don't know, 10,000 or something? Anyway, lots. So you see where it's going, right? So that's the idea. That's why we say wherever the denominator heads to 0, rock it up or rock it down, the graph's going to do that because that's what fractions do when you put things in their denominator really close to 0. That kind of thinking is what you want to do for yourself. All these rules are based off numbers. I mean, they're just not, an x and a y are just numbers we don't currently know, right? So just play with numbers whenever you're getting all these math rules until the point where it makes sense for you. Once it makes sense, you don't need somebody to tell you silly little rules. You're like, I get it. I don't need to memorize a bunch of silly little rules. I get it. The bottom heads to 0, boom, it's got to go up. I know that. That's what you want to get to. So much better than trying to memorize all these little rules is to work that way. All right. So that was all the horizontal. And that was all the vertical. Now we need the horizontal. I'm getting them reverse. All right, so all that was the horizontal. Now come the rules for the vertical. No, I cannot say this right, can I? That was the vertical. Now come the rules for the horizontal or oblique. What's oblique mean again? Diagonal, slant, right? Yeah, so now I'm going to give you 4 big steps, and I'm going to say, don't remember those steps. I mean, you can. Go ahead, put them on your 3x5 card. But much better is the logic I'm going to reason with you afterwards. You can start thinking. How would I know what would make something have a horizontal asymptote? What does it mean? What does it really mean for a graph to have a horizontal flat line that it approaches, right? That's what a horizontal asymptote is. Some kind of line the thing approaches, right? Guideline. As you go right, or maybe left, forever. As x heads to infinity, or maybe negative infinity, right? As you go, as x goes to the right forever, positive, 1,000, 1,000,000, 1,000,000,000, 1,000,000,000,000, the graph height levels off. What makes that happen? So let me give you the steps, but you be thinking about logically why that happens. Basically, well, now that I've said half of it, I'll do the logic first, then I'll write the rules. Think about our function, 13x over x plus 5. Think about what would happen. When you're thinking about horizontal asymptotes, you're thinking about what would happen way off to the right, or left, same thing. So let me just go way off to the right and plug in 1,000. What if I plugged 1,000 in for x? About what would that fraction be? Well, it'd be 13,000. See, I'm just playing with numbers. Over 1,005. See how that plus 5 is silly? That plus 5 isn't doing anything important. And I'm only plugging in 1,000. What if I plugged in 1,000,000 or 1,000,000,000 or 1,000,000,000,000? 1,000,000,000,000 plus 5. Oh, the national debt went up by $5 today. Big news, top story. No, obviously not, right? The national debt's trillions, whatever it is. I don't even want to remember. $5 is chump change. It's absolutely nil, right? So do you see what's happening? When you're going, that's the trick with horizontal asymptotes. You're talking about going right forever. You're talking about x being really big. 1,000, 1,000,000, 1,000,000,000, 1,000,000,000, right? So think about your function. If you plug in a really big x, the 5 is silly. All that's going to matter is the most powerful term on the top and the most powerful term on the bottom. Any lower powered terms added or subtracted are eventually meaningless if you plug a big enough x in. Even, let me just make sure I'm making sense out of that. What if we had 13x squared plus 10,000x plus 1,000,000 over, whatever. I would say he's all that matters. I don't care that x has a big 10,000 in front of it and that's 1,000,000. If I plug in 1,000,000,000, if I go far enough to the right on the x-axis, and I plug in, well, not even 1,000,000,000. How about I just plug in 1,000? 1,000 squared. 1,000 squared, that's 1,000 thousands. That's 1,000,000. That'd be 13,000,000. That would still be bigger, wouldn't it? That'd be 10,000,000. So almost as big. But that's just plugging in 1,000. If I plug 1,000,000 into that thing, he's already totally dominating the other terms. Do you see the point? All that matters if you're going right forever or left, positive or negative infinity, all that matters is the most powerful term on the top and the most powerful term on the bottom. That's all that's really relevant to what's going to happen in the long run to the function. So, okay, so what do? So you just grab the most powerful on the top, most powerful on the bottom. Let me just go to a new screen. And you just say, hey, what are you guys going to do? So I just say, all right, 13x over x plus 5 really is just 13x over x when x is headed to infinity, that is, when x is headed to the right forever. So what's that? Well, that's 13, right? That's what it's going to do. It's going to level off at a height of 13. This is y equals, right? This is y equals 13. It's going to hit the y-axis at 13. Eventually, this function's going to, I don't know if it's coming from above or below, one or the other, I don't know. Can't do both. That'd fail the vertical line test. One or the other. It's going to level off at 13. Eventually, given enough time, it's going to get closer and closer and closer to 13 because it's effectively 13x over x. The 5 is nothing. So we know what the answer is. I don't need somebody to give me some rule. See that? That's what it's got to do. Off to the right forever. And do the same thing to the left. Plug in negative infinity. It would be negative over negative, so it's still positive 13. Right? You with me? It's going to do the same thing this way. I don't know if it's coming from above or below. Actually, I do. It's coming from below because the denominator is a little bigger. X plus 5. Is that true? Yeah, a little bigger than a little smaller because the denominator is bigger. So it's coming from below. Both those are coming from below. So, right? Do you see why it's positive 13 even for negative x values? Because it's negative top and bottom. X is top and bottom. Two negatives make positive. Right? All right, are we good? Are you happy? I'm looking for happiness on your faces. Right? I'm looking, because that's when I know I'm reaching in. You're understanding what I'm saying. Yeah, so let me write out some rules here based on that logic. I'll give you all the rules. So here's the rules for horizontal and oblique asymptotes. So basically, it's all about the degree of the top and the bottom, isn't it? So here we go. Let D equal denominator degree. I'm kind of scribbly there. Denominator degree. N equals numerator degree. So it's basically whoever's a bigger power is going to win the tug-of-war. That's basically what the rules I'm about to write for you. Basically, whatever degree is on the top, whatever degree is on the bottom, as you plug in 1,000, 1,000,000,000, 1,000,000,000, going right forever, the numerator is trying to pull the function up to infinity, and the denominator is trying to pull the function down and flatten it to 0. And they're going to tug a war, and whoever's got a higher power is going to win. That's basically it. So it's all about the power on the top and the power on the bottom. Number one, if the denominator is bigger than the numerator, then he's going to win. Like if you have x to the 5th on the bottom, x to the 4th on the top, you plug in a really big number, right? You have x to the 4th over x to the 5th. On the bottom, you plug 1,000 in for x there and there. The bottom is going to be 1,000 times bigger than the top. He's got an extra 1,000 multiplier, right? He's going to win. So this is going to be 1,000 to the 4th over 1,000 to the 5th, which is really 1 over 1,000, right? And I'm only plugging in 1,000, let alone 1,000,000. 1,000,000th. What if I say, hey, I'm going to give you, I brought cookies to share. My wife made some cookies. You can each have 1,000,000th of a cookie. What is that? That's just the smell of the cookie, right? I mean, that isn't even, right? That's not even a flake. That's nothing. That's 0, isn't it? The denominator wins. Y equals 0. Horizontal asymptote line. It's going to flatten it, right? That graph would go flat eventually, wouldn't it? Because the denominator wins. 1,000th, 1,000,000th, 1,000,000,000th of a cookie is no cookie, right? It's virtually nothing. So y equals 0. It's going to flatten it out. That makes sense? For that case, let's do case 2. What if they're equal? What if the denominator and the numerator have the same powers? They're both x to the 5th. Well, then they're going to tie. And whatever numbers in the front are there are going to be the story. Let me show you. So if you have 3x to the 5th plus 17x to the 4th plus whatever over 7x to the 5th minus 12x to the 4th plus whatever, all that matters is these guys. The lower powered things don't matter since we're plugging in such big x values, 1,000, a million. Okay, so it's going to basically be 3x to the 5th over 7x to the 5th, and those cancel. It's going to be a, or it's going to be 3/7. It's going to be a over b, where a and b are the coefficients. A and b are the coefficients in front of the biggest powers, right? Does that make sense? So in this case, y equals 3/7. What you might think, what is that 3/7? Well, that's like half. There's 1, there's 2. 3/7 is just below half, isn't it? Here's 3/7. It's a horizontal line just below a half. And that means the graph will eventually level off at 3/7. So it doesn't flatten it all the way, but it'll tie. The numerator and denominator will tie in the tug of war, flatten it off at whatever the a over b is, effectively, eventually, as you plug big enough x values way off to the right. Make sense? All right, we've got 2 more cases. That's not yet the whole story. There's a lot to this story. All right, we're still finishing up horizontal, oblique. I already told you if the denominator's bigger, it's y equals 0, horizontal asymptote. If they're equal, it's y equals a over b, flat asymptote, horizontal. Now, what if the numerator's the bigger one? What if the top is bigger? Well, then he's going to win. And what does the top do? He pulls it up, 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 up to infinity, huh? So if the numerator is a higher power than the denominator, he's going to pull that thing up to infinity. But there's different ways you can do that. If he's only bigger by 1, then he's going to pull it up in a linear fashion because it's 1 degree higher. So like, for example, if you have, let me change the number there. If we have something like 7x to the 4th plus, blah, 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 over 3x to the 3rd, he's 1 higher than him. So and they're all that matter. Lower power stuff doesn't matter. So if you reduce that, it's 7/3 x, isn't it? Right? The x to the 3rd cancels into the x to the 4th. What's that? That's like y equals mx plus b. That's what a diagonal asymptote line is. It's going to head off to infinity, up forever, but in a linear kind of fashion. Because the top is only beating the bottom by 1. So it's first degree. When you cancel them, it's first degree, right? X to the 4th divided by x to the 3rd is x to the 1st. It's linear. It's heading off, up and to the right forever, but in a linear fashion. It'll eventually get super tight to some kind of a diagonal slant asymptote. That's when you get the oblique asymptote. Whereas case 4, if the numerator is greater than the denominator by 2 or more, right? Say you got x to the 5th, 7x to the 5th over 3x to the 3rd. You reduce that, you're going to get 7/3 x squared. So he's beating the denominator by 2 or more. So he's going to pull it up curved, isn't he? He's going to pull it up like an x squared. And so we just lump all those together and say, look, there's no horizontal, there's no diagonal. It just rockets up. The numerator wins, no flattening out, no lining out. It just curves up and out. That's the 4th case. So, all right, I've talked forever about these. Let me summarize them finally. All right, so here we go. Here's the final. I really mean it this time. The horizontal, oblique, asymptote story. Case 1, denominator greater than numerator, y equals 0, horizontal asymptote. Case 2, denominator equals numerator, y equals a over b, flat asymptote, horizontal. Case 3, numerator is bigger than the denominator by 1. That's an oblique or diagonal asymptote. Now, how do you find it exactly? You got to divide. You've actually got to divide that bottom into the top. That's a little painful. I'll show you one of those. You got to go denom into numerator. And when you do, up here you get the mx plus b. That's your oblique asymptote. It's the answer to the long division. Those are painful. So, and then finally, case 4, when the numerator is greater than the denominator by 2 or more, no horizontal or oblique asymptote. Right? Because it goes, the numerator just beats it too badly, and it just curves up forever, like x squared or better. It doesn't line up or flatten out at all. The numerator just pulls it up really quick. Those are the 4 cases. So you can put those on your 3x5 card, but even better if you can sense them. So we'll do the rest of the problems in this section using that chart. So everybody got it down? So I will move on then. All right, so here we have one. So we have y equals x squared over x to the 4th minus 81. Oh, they want us to find, I forgot all about the vertical. So let's do the vertical first. So all right, can you find the vertical? Find the vertical asymptotes. Then we'll do that whole horizontal oblique thing. So what's the vertical asymptote? How do you do vertical? Did you forget that while I was talking about horizontal oblique forever? So vertical, remember, that's what makes the thing go up. What makes the thing go up forever? Why would a graph go up forever? Denominator gets close to 0. That's what makes a fraction rocket up. Denominator close to 0. So you grab that denominator and say, hey, denominator, what's going to make you 0? Oh, I was supposed to reduce or whatever. You can't reduce this thing, huh? There's no reduce. You can't cancel anything up there. So I just go denominator 0, move the 81 over. What do you do to solve that? 4th root it. 4th root. And whenever you do an even root, not an odd root, but an even root, you got to do plus or minus. Not an odd root. Odd roots keep signs, right? All right. So x equals plus or minus 3, right? 3 times 3 times 3 times 3, 4 times is 81, right? Plus or minus 3. So the vertical asymptotes, that means at plus 3 and at minus 3, this graph would have verticals. Maybe it goes something like this. I don't know. I'm just making it up here. Something like that. Verticals at plus 3 and minus 3, because the denominator is 0 at plus 3 or minus 3. So you get close to denominator 0, you're rocketing up or rocketing down. Okay, there's that part. Now, the more complex horizontal oblique, but in some ways quicker. All right, try it. What's the horizontal oblique? Look back at those instructions if you need to. Here's the instructions. Did you get them all down? There's the instructions for horizontal oblique. So look back here. So we're talking about, what's the numerator degree? 2, denominator degree 4, right? So the denominator is bigger than the numerator. If you plug in 1,000 for x equals 1,000 or 1,000,000 or 1,000,000,000, the denominator is just going to win the tug of war. It's going to pull it down, flatten it out, y equals 0, horizontal asymptote. Right? That's what the instructions said when denominator is greater than numerator. Is that good? Bottom wins the tug of war. All right, so we got that one's factoring, guys, and we don't got time. I wish I had time to let you all try to factor and do some more instruction on factoring, but we don't. I don't have time for everything. I'm glad to help you in my office hours. Roberto will help you. His hours are listed over there. But you've got to be a good factorer. You will not make it through calculus if you can't factor. If you look at this kind of thing and you're like, I don't know how to make that work, my answer is practice. You got to practice. You got to guess. Just guess. If you look and go, I don't know. Maybe it's 5x and x, and I don't know, maybe the 3 goes here and the 1 goes there. No, you're wrong, but go ahead and guess. Guess means foil it. It doesn't mean just write at it and stare at it. It means foil it out. 5x squared minus 5x plus 3x minus 3. And you go, oh, no, that's not working. The middle term's only minus 2x. It's supposed to be minus 14. Oh, let me try to change something. And then you change it, and you try it again. You change it, and you try it again. You change it, and you try it again. And pretty soon, you become a good foiler, and you can do it backwards in your head. That's what happens. You need to just do it again and again and again until you can do that backwards in your head. So I'll come up here and just do it. It's going to be 3 here, 1 here, minus and plus. Yeah, that's correct. You could foil that, and you'll see it's right. Probably a lot of you already know that's right. So it's going to be 3 here, 2 here, minus plus 2 minus 9. Yeah, that's right. All right, so I factored them both, and then notice what happens. Remember, for vertical, I'm doing the vertical asymptotes first. For the vertical, we're supposed to factor and cancel. So those cancel. So that's step 1. Step 2, you're supposed to take the denominator. So what's left of the denominator? Just 3x plus 2, and say it's supposed to be equal. Remember, domain, we say it cannot be 0. It's not allowed. Vertical asymptotes, we say it's at equals 0 that it happens. Move the 2 over. Negative 2 divided by 3. There it is. There's the vertical. X equals negative 2/3. That means if I was to do this graph, here's negative 1. At negative 2/3, there would be a vertical asymptote line. Because negative 2/3 makes the denominator 0. Is that good? I've got to do the horizontal for this thing. And the time is running. I got to get another section done. I knew I was going to go too long on that vertical, horizontal thing. All right, let's do the horizontal oblique. That's the second part of this one. So numerator degree, denominator. What's the degrees? 2 for both. In other words, you just grab the highest power top and bottom, huh? It's just going to be 5x squared over 3x squared. That's really all you have to do. These cancel, 5/3. That's y equals. So it's y equals 5/3 flat asymptote line, horizontal. That means 5/3, what's that, 1 2/3? So that means at 1 and 2/3, between 1 and 2, we have a flat asymptote line. Because the numerator and denominator in their tug-of-war will tie. And the numbers in the front, 5/3, will determine the landing point, the flattening out line. The graph will eventually flatten out like that. Good? Questions on that? Sure, a lot of screen flickering today. All right. So, let's do this. So, for the vertical asymptotes, again, you got to factor. So you got to be able to factor. So lead me through it. Can somebody factor there? So remember, I just write FOIL. I write F-O-I-L. And I say front times front to make 15x squared. What times what makes 15x squared? Yeah, 3x, 5x. The order on the first two doesn't matter. The order on the back two does. So now do the last. I save the O-I, the oi, in the middle to do at the very end. So front times front, right? I write FOIL over those three terms. F-O-I-L, FOIL, F. Front times front, 3x plus 5x is front. Last times last is 20. Don't worry about the negative. We get the signs later. What times what makes 20? 5 and 4. You never want a 5 in the same parentheses with another 5. That'll never have two numbers in the same parentheses that have anything in common, let alone the very same number. You can't have 5 and 15 because you can factor out a 5. And any factoring common you would have done previously in the first step, right? If they all had a 3 in common, I would have already taken that out. It can't be showing up later. So if the 5's anywhere, it's there. Is that going to work? Yeah, it is. Plus, minus. I'm doing the oi in my head. I'm looking at that going, that's plus 25. That's minus 12x. And that together makes plus 13x, the middle term, see? That's what I'm doing because I foiled a million times. So foil, 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 and you'll be able to do that as well. These cancel. And so That's all step 1. Step 2, you're supposed to take the denominator and set it equal to 0. What do we have in the denominator now? So we have no. So we have no denom, because it canceled, so we have no vertical asymptote. This graph has no vertical asymptote. It has no denominator after the reduction. So nowhere for the denominator to become 0. So there's that. Now we need to do the longer, more painful. It's going to be an oblique asymptote, isn't it? Did y'all see that? So this one now it's time for horizontal oblique. And the numerator degree is 2. The denominator degree is 1. So the numerator is greater than the denominator by 1. So that means you have to long divide denominator into numerator, and you're going to get an oblique. You're going to get an mx plus b thing up there, and that's going to be your oblique. So let's long divide. Probably been a long time, if ever, that you've long divided polynomials. So we got to long divide the bottom into the top. You can't just cancel the front terms. That'll give you the m, but you won't know the b. And the mx plus b, you know? We got to get, this is going to be a slant or diagonal asymptote line, right? Because the numerator wins the tug of war by just 1 degree. So he's going to pull this graph off to infinity linearly, in a linear fashion, right? We got to find the equation of that line that is the diagonal asymptote line. All right, remember long division? Remember numbers? Probably been, we all just hit the buttons on the calculator, me included, right? Who long divides by hand anymore? Remember how to do it? Like what if we had like 21 and 87? How would you know what to start with?
First number.
Yeah, first number, huh? You'd go, well, 4, because 4 times 2 is 8, huh? You make the first number work. But it doesn't just go there, it also goes to the other one, and then you subtract, huh? Same thing with the letters. You look at the front and the front, just like we looked at 2 and 8. What do you put up here? Times 3x, that'll make 15x squared. 5x. So 5, let me erase that, for 5 and x, exactly. So 5x. But it doesn't just go there, it also goes there, just like the 4 went to both, huh? So 5x times 3x is 15x squared, and 5x times 5 is 25x. Good so far? And then we subtract, these cancel. 13x minus 25 is minus 12x. Bring down the minus 20. What do we do for the next step? We again look at front, and we say, what do I put here? Times the front that will match the front. And we mean match exactly. Same sign, same everything. It's got to be identical twins so that when you subtract them, it's 0. Can't be opposite sign. So what times 3x will exactly make negative 12x? Minus 4, huh? So that'll make, well, you know, actually, I don't even care at this point. There's my equation. 5x, that's my mx plus b right there. You don't even need to finish it. The rest, who cares? Remainders, who cares? This is all we need. Y equals 5x minus, am I on the screen still? Yeah. 5x minus 4. That's our mx plus b. That's our oblique asymptote. You can asymptote line. You can put that on the graph, but I don't have time. There it is. That makes sense on that? It's a little painful. Feel free to look back at that. Okay, it's gonna basically ask you all the same stuff that we just did in the last section. So it's gonna say, what's the domain? So how would I find the domain there? Yeah, denom cannot be 0, right? That's what we're not allowed. No knives in the toaster, no 0 denominators. So we say, all right, denominator, you can't be 0. So you know that means x cannot be 0, x cannot be negative 18. So that would be answer A. Good. B will say, find the horizontal asymptotes, find the vertical, all the same stuff we've been doing. The last part, D, will say graph it. And I'm going to say, just use your graphing calculator. And that's what you'll be allowed to do on the test. On the test, these will be on part 2. Part 2, so you'll be able to use your graphing calculator. So, but you will need to find horizontal and vertical by hand, and then use the technology to see how the graph fits around those horizontal and vertical asymptote lines. So it's a putting together of technology and by hand calculation. So nothing else new there. 9 is definitely, so the other ones 1 through 8, they really are not different than what you've seen before. They're just, you got to do that long divide thing we did a few minutes ago, especially on 3 and 6. I'm not going to have time to go back to them. So on number 3 and number 6, you got to do the long divide diagonal asymptote thing that we did a minute ago. So let's go on though. Number 9's a little different. They're just giving you a different look than you're used to seeing. They're going to ask you all the same questions, domain, da-da-da-da-da. Okay, so first off, let's do the domain. That part won't be hard. Domain, denom, not equal 0. So that's just the x, huh? X can't be 0. That was easy. So, but now the next question is going to ask you for the vertical and horizontal asymptotes. So let's do the vertical first. How do we find the vertical asymptote for that function? That's denom equal to 0, huh? So you guys getting the difference? Domain denominator not equal to 0. Vertical asymptote denominator equals 0, right? Because you want to know where is the thing. So in domain you say you can't go there. And then vertical asymptote you say, yeah, I know we can't go there, but where is it? Right? And you're saying equal, right? So that would be x equals 0. So it's virtually the same, huh? And then now how about horizontal on this one? Horizontal. You probably aren't noticing it's y equals x plus 9 over x. You must make it one big fraction to use the given rules. The given 4 rules I gave. You know those 4 rules, denominator, numerator, all that. That was when it was one big fraction. I'm going to have to combine these, put this over 1, common denominator, put them together into one big fraction. Then I can use those 4 rules. Does that make sense? I want to make sure I gave you that information. Let's do that. So if I can skip over here and say, okay, so for the horizontal, so for the horizontal oblique asymptotes, I gave you the 4 rules, but first combine into one fraction. So all those rules I gave you were for something that is one big fraction. So I've got to take x plus 9 over x, put this over 1. What am I going to do to make those into one big fraction? Yeah, top and bottom by x. So that'll become x squared over x plus 9 over x. Now they have the same denominator, x squared plus 9 over x. There it is combined. That's the same as it was before, but now we can use our rules. Does that make sense? Do you see what I did there? I just multiplied top and bottom of this guy by x, right? That doesn't be the same thing top and bottom, so I didn't change it. Right, x squared over x, that's just a fancy x if you reduced it, right? But now they have the same denominator. So I can combine them into one fraction. Now I can do my denominator degree. What's the denominator degree is 1, the numerator degree is 2. The numerator is bigger than the denominator by 1. So that's going to be oblique, isn't it? You with me? Numerator bigger than denominator by 1, oblique. Oblique, diagonal, asymptote. So that means I got a long divide. I don't know if I have time for that. How many more questions we got here? So I'll come over here and long divide it. All right, so come over here. So I'm going to go denom into numerator. So that would be, what's the denom? X into the numerator, x squared plus 9. You with me what I'm doing? Do you see why I'm doing this? Because when I combined them, the numerator had 1 degree higher than the denominator. That means it's oblique. It's linear. It's going to head off to infinity in a linear fashion. So divide x times x is x squared. Subtract 0, bring down the 9. All right? 9's just the remainder. There's no x there at all. That's it. It's just y equals x. Y equals x. If this had like an x or something, then I would put a 9, you see. But it doesn't. So I'm just done there. You don't need the remainders, remember. You just need what's up here. Whoops, I just erased it. You just need what's up here. That's your asymptote line equation, y equals x. Makes sense on that? So, get a graph done and a word problem done. Okay, so try that one. All they want you to do is graph it. They don't want the horizontal and vertical. Yeah, I'm going to skip this one, guys. I didn't realize they don't want you to do. How do you look at that graph and work backwards to the right equation? Well, there's a lot of things you could do. Notice that it's got down here at -3, it's got a horizontal, and at -2 and +2, it's got a vertical. So these guys are out because the denominator's wrong. X squared plus 4, that doesn't factor. You need x squared minus 4, because that'll be x plus 2, x minus 2, and that's what gives you the -2 and the +2 verticals, right? So it's either B or C because of the denominator being correct. Okay. Now how do you know which of those is right? Yeah, the only difference is the negative sign. Which one should have a negative sign? I don't know. I think it should be B, shouldn't it? If you plug in 1, oh no, I'm wrong. Here's what you know what I'm doing, guys? I'm just plugging in 1 in my head. You know me, I just always play with numbers. I'm just saying, well, I don't know. I'm not gonna do anything amazing. I'm just gonna plug in x equals 1 and see if the thing's up or down. If you plug in 1 to this guy, you get 3 times 1 squared over 1 squared minus 4. You get 3 over -3. You get -1. So this guy would be over 1 down 1. Over 1 down 1 would be there. Would be there. Is that where the graph really is? No. Answer C. So I did a little bit of looking at asymptotes, and then I just plugged in a number on that. All right, so a rectangular area adjacent to us. So we have a river, and then we're going to do like a rectangle next to that river. No fence is needed. You're holding in some critters. You got a river to hold one side, and then you got the 3 sides that are fenced. The enclosed area is 1,000 square feet. Fencing for the side parallel to the river, that's this side, that's parallel to the river, right, is $6 per foot. Fencing for the other 2 sides is $3 per foot. The 4 corner posts are $35 each. 1, 2, 3, 4. 4 posts, 4 times $35. What's that? 140 bucks. 70 twice. 140 bucks. The 4. Let x be the length of one of the sides perpendicular to the river. Like x is like that and that. Right? Those are perpendicular to the river. They hit the river at a right angle. They're both x. Write a function, c of x, that describes the cost of the project in 1 minute. I'll do it in a minute, but we're going to have to put this off. This won't be due, but let me do this one and we'll stop. Right, because we stop at 40 after, right? Mm-hmm. I'm not wrong. We only got like a minute, right? Mm-hmm. All right. So what's the cost there? So basically I'll just do it, and we'll do it probably again next time. So the cost is going to be 3x, because it's $3 per foot, x feet of fencing, plus whatever this costs. Oh, plus the set of the 140, I should say, plus whatever the right side costs. So we have the $140 for the posts, right? The 4 $35 posts. We have the 3x for the top, 3x for the bottom, and then we got to add whatever that right side costs. What's the right side going to cost? Well, 6 times however long this piece is, because $6 per foot. But how long is that piece? How long is that piece? Call it y. Call it y, because I don't know what it is. 6y. Does that make sense so far? Now, they want this to only have x. That's what c of x means. They don't want y. So how do I get rid of it? This guy. Area. What's the area of a rectangle? Length times width. The 1,000 is x times y, right? X times y. So I can solve for y. Y is 1,000 over x. Plug it in here. We'll do more of this next. Then we'll have the function for x. All right, we'll do more next time. Let's stop.